Hi everyone. So with our newly made cheat sheet, printed or referencing it, we are going to look at finding the area of what's called composite shapes. So this is just a fancy way to say funky shapes or shapes made up of other shapes. I call them Franken shapes because they appear to be stitched together of multiple different shapes. So here are a few examples. We have this one. We have this one that's kind of like a little boat. We got this crazy weird shape. So what they are just shapes that are made up of multiple other shapes. And our job for all of these shapes today is just going to be to find the area. So how much space is being taken up by this weird shape? So we'll work through a couple examples together. The first thing you gotta notice is what shapes are forming the shape we're given. So if I look at this one, I see an end that kind of looks rectangular, and then I see a pointy end. And so when I'm thinking about pointy things, I'm probably thinking it's gonna be made up of a triangle. So I'm gonna do my very best to turn this shape into a rectangle and a triangle, because that's what I think it is. Okay, there's where my rectangle ends and my triangle begins. And since since this is a rectangle, I dropped this line straight down. I actually dropped it in at a 90-degree angle to make it a rectangle, which means there'll also be a 90-degree in my triangle. So now I know my total area of this shape is gonna be made up of the area of the rectangle and the area of the triangle added together. So my total area will be area rectangle plus area triangle. And so my job is going to be to find the area of both things. So let's check out my rectangle. We'll start there. So in my rectangle, I'm seeing a lot of different measurements written on here. So let's see if I can figure out what all these measurements are for. It looks like there's a 10-inch measurement here on the side. So that means that the other side of the rectangle is going to have a 10-inch measurement too, because that's how rectangles work. I'm just going to write 10 in my picture, but remember it's inches. And then I have, on this side I have 21 inches, and down here I have 25 inches. So what I think that means is that my rectangle side is 21, but the whole side is the 25. So that means that this much inside the rectangle is another 21, and that would mean that this leftover bit here in the triangle, that has to be 4. So that together, the 21 and the 4 make that total 25 inches. And now I'll find the area of each of my pieces. So for my rectangle, I need to do length times width. So if I look at my rectangle, it appears that my length is 21 and my width is 10. And if I do that in my head or in my calculator, I'll find that that is 210 inches squared, squinches. So just my rectangle is 210 inches squared. And now I'll do my triangle. So my triangle has a different formula. The area of a triangle is half the base times the height. So if I look at my triangle, I'm going to remember, okay, Well, this is a triangle and it is a right triangle because there's a right angle. So my base is along the bottom and my height is the other side, making that right angle. How tall is it from top to base? So I've got those two measurements. Half my base, which is 4, because the triangle is just this much, times my height, which is 10. And I'll calculate. So half of 4 is 2 times 10 is 20 inches squared. So I found the area of the rectangular part, I found the area of the triangular part. And now for my total area, I'll add those two things together. So my total area equals 230 square inches. Notice here that I really neatly tried to organize my work so that the triangle area and the rectangular area were separate and I could tell where they both went to. But maybe, you know, that might not work for you to do it the same way as me. So in the next problem, I'll show another way I think might help to show your work. Okay, on to our next shape. Our next composite shape looks like a little boat here, and they kind of gave me a little bit more of a hint on this one because they drew in the line for me that connects my two shapes. But I see that I have a rectangle and I have a semicircle. So I'm gonna make a spot in my work to find the area of both of those things. So I know I'll need to find the area of a rectangle, sorry, not a rectangle, a triangle. I hope I haven't been saying rectangle this whole time. And I need to find the area of this semicircle. And I don't have to draw it to scale. It's just kind of to remind me where things are and what shapes I'm looking at. So now I'm going to go through and I'm going to think about what information they've given me in my two measurements over here of being 6 centimeters and that being 2 centimeters. So I guess I'll start with that 2 centimeters. It looks like it's just the side of my triangle here. I think that's the only thing it's talking about. So I'm going to fill that in over here too, which is great because that's the height of this triangle. If we notice again, we have a right triangle. So, right, the height would be there and the base is there. So I have one of those two. So I need still to find my base. And then I'll go over and I'll look at this 6 centimeters. So it appears to me that the 6 centimeters, it's only marked off on this side. I think it's representing the radius of this circle. So the 6 centimeters is going to be for the radius of the semicircle. And that'll help me find the area because all I need for this is the area of a circle is a radius. But it's also going to help me find the base of this triangle. So if this is 6 centimeters here, a radius, this side is also 6 centimeters. Because it's also going from the center to the edge. So that means that the base of my triangle is also 6. So sometimes I like to recopy these drawings over with just their important measurements for each part of my shape. And now I'll find the area of each. So the area of my triangle is half base height. And so I'll fill that in. Half the base, the bottom is 6, and the height is 2. And then I'll calculate. So half of 6 is 3, times 2 is 6. And I'll fill in my unit, because it's my final answer for my triangle. So it was centimeters, so centimeters squared, squentimeters. Then I'll go over and find the area of my semicircle. So to find the area of a semicircle, that's half of a circle. So I need to find the area of the whole thing and then divide it by 2. So here's how I show this. Okay, so for my whole circle, there's my center, my radius. The area is pi r squared. And I know that my radius is 6, so I'll fill that in. Pi times 6 squared. So 6 squared is 36, and 36 times pi will give me a rounded answer. Now I would prefer that you use a rounded answer, rounded to 1 or 2 decimal places, because it's gonna make it so you can add your terms together. So we do always wanna get our rounded one. So I'm getting 113.1 as my rounded answer. And that's centimeters squared as well. So my half circle takes up 113.1 squentimeters, and this little triangle on top takes up 6 squentimeters. And so my total area would happen if I added those two together. So I take my 6 centimeters squared for my triangle, and I add that to my 113.1 centimeters squared for my half a circle. Oh, I made a mistake. That would be the area for a full circle. Oh no! If I want to find the area for a half circle, I need to cut in the area of the full circle in half. So my half circle, oh geez, is gonna be 113.1 divided by 2. I got too excited here, folks. I calculated 113.5 divided by 2, and I got 56.55. So hopefully you caught me before I caught myself, because if you did, congratulations. But those are the numbers I need to add together. Half of the circle and the triangle. So that's what I'm gonna do. 56.55 plus 6 is 62.55 centimeters squared. So that would be my total area for that shape. Here is proof that everyone makes mistakes, and that's okay. All right, one more. In our last problem we have here, I've got a pretty funky looking shape. It's kind of like the first one. There appears to be a rectangular end to this, and there is this slanted line, which makes me think of a triangle, but the piece left over after I make a rectangle is not a triangle, but I'm gonna do that anyway. I'm gonna split this up and make this into a rectangle, because I know that that's at least gonna be part of my area. Sometimes we use dashed lines to show that that line doesn't really exist here, but it is helpful in seeing the picture. So I'm gonna say there I have a rectangle there, and then, okay, and then it looks like, well, I could make a rectangle out of this piece, and then I'd have a triangle on the other side, triangle and rectangle. So I'm gonna do that. Okay. So now I see three shapes. I see two rectangles, boop, boop, and a triangle made out of this big funky shape. And so in order to find the area of these pieces, I'm gonna need to think about like what the measurements are. So in my top rectangle here, it looks like it's an 8 by 6 rectangle, and then that 16 is for this whole side. So that's gonna be one of the things I draw. My top rectangle is a 6 by 8 rectangle. Then I have this skinny little rectangle. And they tell me the bottom is 2, but I don't know how long the side is. Okay, so let's think about that. Well, the side is this side right here. And this side is part of that 16. If in my rectangle here, both of these long sides are 8, and this whole part is 16, then this side down here also has to be 8, so that the 8 and the 8 make the full 16. So I'll put that over there in this little version of my thing too. And then I have this triangle. So this triangle looks like a right triangle to me. And I can tell that this side here of the triangle is going to be 8 because it's also a side of this rectangle. So if this side is 8 on the rectangle, then that side's 8 on the rectangle. And so that means that in the triangle, it's also 8. So in my triangle, which is all sorts of upside down, ooh, I know it's a right triangle, and this side is 8. Okay, and then the last thing I need is I need another measurement. I need this side, right? If this is my base or my height, I'm gonna need the other side here. So that's up here, that. Well, what do I know? I know that in the top rectangle, this down here is 6 because that's the same. It's also 6. So all the way across here, from one side to the other, is 6. So I know that at least that this is less than 6 units long. It's actually going to be 6 minus whatever is on this side, that little piece. And so if I look at it, okay, well, this piece is part of this rectangle. So it's the same as this side, so it's also 2. So if this is 2 and the total length is 6, then that length has to be 4. And so I got all my measurements that I need. This is a tough problem, and tomorrow I'll actually show you what I think is an easier way to do this problem, but for now we'll continue on with our areas that we found. So first thing we did, break up the shape. Then we kept breaking it until we saw that this shape actually had 3 of our basic shapes, our building shapes to it. And then I went through and I tried to find the measurements. Using what they gave me, could I find my measurements? So I did. All right, here we go. I need to find the area of each of these 3 things using my formulas. So I have 2 rectangles and they both have the same formula. Area equals length times width. So I'll fill in my important information. Doesn't matter really what you call your length and your width. I always call my length the longer one, but just because length long, I don't know. But here I will multiply 6 times 8 is 48, and then my unit is feet, so square feet. Then in my short skinny triangle, the length was 8 and the width was 2, and so that means that was 16 square feet. And then finally in my last triangle, this triangle doesn't look like what we're used to looking at for a triangle, because the base of this triangle, the part that's on the bottom, is the point. So I'm just going to turn this triangle around until it looks like I'm used to. Oh, there we go. So now I have my triangle that has a base of 4 and a height of 8. So I'm going to use those as my values, and I'm going to do my work upside down here. So my triangle, the area is half the base times the height. My base was 4, so half of 4 times 8 for my height. Half of 4 is 2, and then times 8 is 16 square feet. All right, coming back from a quick break because my phone ran out of storage. We had just found the area of all 3 of our pieces here, and our job was to find the total area of this shape. So I'm going to take the area of each piece and add it together. So the area of the top triangle, 48 square feet. The area, rectangle, pardon me. The area of the smaller rectangle was 16 squeets. And finally, the area of the triangle was also 16 square feet. So I'll add those all up in my handy dandy calculator. 48 plus 16 plus 16, and I get 80. So the total area of this shape is 80 squeet. All right, see you soon for another video about areas.